Okay, functional group. If you want to pause the video and define functional group. Okay, I'll quickly run it down and say that a functional group is a group or is an atom. Is an atom, comma, group of atoms or radicals or bond common to homologous series which determines the main chemical properties of the series. Or in one way you can say that functional group is the reactive group. Of compound, mainly organic compound. So that's what it means. Okay, a functional group is an atom, can be a group of atom or radical or bond common to homologous series which determine the main chemical property of the series. That is functional group. Okay, in this video we're going to be looking at different functional groups, basically alkanals or alcohols, from which alkanals are derived, alcohols, which is the functional group is OH. Okay, now look at this. I have ethane. I can change the E ending with O, and then I have ethanol. When it was an ethane, if it's ethane, you have something like this. This is ethane. This is ethane. So when it is changed, the E is changed to OH. That means I have to introduce an extra OH. Before being ethanol, ethane. One of the physical property of this ethane is that it is insoluble in water. One of the property of this ethane, it is insoluble in water. And then what property that gives ethanol, changing this E to OL and then changing this H to OH? What property that gives ethanol its high boiling point and its solubility in water is due to the presence of OH. I just mentioned two physical properties now. One is solubility, one is the boiling point. If you compare the boiling point of ethane with that of ethanol, we tend to have high boiling point than ethane because in ethanol there is a hydrogen bond that is existing. And where is that hydrogen bond? It exists in that OH functionality or functional group. Okay, they compare with ethane. Ethane has no function. Ethane has no hydrogen bond there. So you should expect that its boiling point should be lower compared to that of ethanol. And then secondly, what account to the solubility of ethanol in water is also due to its what? Hydrogen bond that is existing. And this hydrogen bond exists particularly in that OH functional group. So when we define functional group, we try to mention facts and figures. One, you must say it is an atom. Sometimes you see it coming out not as group, this is group now. Sometimes you see it as Cl, you see it as X, or you see it as oxygen. These are functional groups, but in this case, they are very common to homologous series. All homologous series will tend to have the same functional group in common, and which determines the main property. Sometimes I want to do chemical. The main property of the cell. So the main property of alkanol is wholly determined by its functional group, which is the OH. That's why I can also call it a reactive group of a compound, a much reactive group of a compound, because this particular compound there will be overall destruction of electron. Your electron tend to pull towards oxygen and the hydrogen, so making this side partially negative and here partially positive. So in chemical reaction, the particular reactive part here is the functional group. So that is functional group. So we're going to be looking at some common. We're going to be looking at some common functional group in most organic compounds. Okay. Now, let's begin with alkanols. Alkanols. The functional group of alkanol is O. I always want to give oxygen 2 bonds in organic chemistry because it has 2 unbonded electrons, which when used in chemical bonding give us 2 bonds. 1, 2. I always like to give oxygen that 2 bonds and then give hydrogen just 1 bond. Okay, this is the functional group here, which you can call hydroxy group. Hydroxy group. Okay. So that's the functional group of alkanol. So I'll give an example. Remember this. Here is an open chain. I'll be giving an example here. It has one open chain here, which can be open to R. R means alkyl. Supposing that what is here is CH3. Okay, what name is given to this alkanol is methyl alcohol, if I like, or I can call it ethanol, methanol. Okay, let me just put a space. I can call it methanol or methyl alcohol. Methyl is alcohol. Okay. So we have ethers or ethers. Okay. Ethers is an atom, not group of atoms. This is group of atoms. Ether is just oxygen. Okay, that's the functional group of the homologs. And then ethers is a case where you have this oxygen, okay, having 2 open chain, R. Okay, so that's what it is. This place is our open chain. So what if the open chain is connected to carbon that must have 4 bonds, and then this is also carbon that must have 4 bonds? Okay, that will give you a fact that this is okay. This is a name of an ether, which I can call alkyl 2. So the same alkyl we use was as dimethyl what ether. Okay, that's the name there, or methoxymethane. Okay, we have alkanals. Alkanals. The functional group is carbon linking to oxygen via a double bond, remember, and then carbon must have 4 bonds, and then okay, once you have from here to here, it's called carbonyl. It's called carbonyl group. Okay, this is carbonyl, or this time we link into hydrogen. Okay, so that carbonyl just has just an open chain which can link to this. So what it means is CH3. So 2 carbon atoms are in this chain. So this is ethanol. ethane is 2 carbon atoms. So it is a functional group. So since it's linked to this, so I'll give an example here as ethanol. So, but if this is ethanol, what will be the molecular formula, structural formula for methanol? Yes, both are successive member of ethanol is methanol. So the difference in the molecular formula, since meta is 1, is this. So difference in the molecular formula would be just CH2. So if I take away CH2 here, and we have only H remaining. So this is the structure of methanol. Methanol. Okay. 4 alkanones. Alkanones. A ketone group as well. But this time, just like alkanals, alkanones are also carbonyl. Or this carbonyl has 2 open chains. So just carbonyl, or you can call it ketone group. Ketone group. Ketone group. Okay, and so now that is over 2 open chains. Okay, so here I can have carbon forming link. So you can have this as 1, 2, 3 propane 2O will be there. Propane 2O. Good example. Okay. 5. We have alkanoic acid. Alkanoic acid is also a carbonyl group, but this carbonyl this time linked to OH. So having just 1 open chain here. So if that is the case now, you're going to have, so what if there, that is it, and here is linking to carbon, carrying 4 atoms of carrying 4 bonds. So what name is given to this alkanoic acid? Alkanoic acid is 2 carbons, so this is ethanoic acid. Ethanoic acid. So if this is structure of ethanoic acid, so metanoic acid will be also just take away CH2. So what will happen here is also just H. So this one is metanoic acid. So what would be the simplest? Okay, let's simply say is ethanoic acid. Okay. 6. We have alkaloids. Alkaloids or esters. Esters. So what's it? The big deal is that's esters. So 2 open chains are there. COR. Let's see, R is CH3 here. R is CH3 here. So one name is given to this. This is methyl ethanoids. Methyl ethanoids. So name here is methyl ethanoids. Okay. And then amides. Amides. Amide is also a carbonyl that is linked to NH2. That's amide. So what if this open chain is linked to CH3? So one name given this amides. Okay, this is eta. Eta means carbon 2. Ethanamides. Ethanamide. If it's ethanamide, what will be the formula for methanamide? Methanamide will be, this time we're going to take away CH2, so I have H. So this is methanamide. So ethanamide is my example. Ethanamide. Okay. Amides. Yeah, most times I don't know the difference between amides and amide. Amide is just NH2. NH2. Just one open chain. It's amides. So amides, N is what again is linked to CH3. So what you have here is what? This is methyl. This is methyl now. This is methylamine. Methylamine or methylamine. Methylamine. So let me use methylamine as my example there for amine. Methylamine. Methylamine. As pronounced. Okay. 10. I have them. Alkenes. Alkenes is one organic compound that does not have any functional group. Functional group is me. Alkenes is carbon double bonds. Alkynes is carbon triple bonds. So example of the alkene, the simple one is what I'm going to use is ethene and the ethane. Okay, please. These are a few common homologous or families of organic compound with their functional group. The only organic compound without functional group is alkene. Example is methane. The only organic compound without functional group is alkenes. The double bond is the functional group of alkenes. The triple bond is the functional group of alkynes. Okay, this is on the functional group. So these are the families, and look at their functional group. So now listen, there are carbonic groups from here. All I come with carbonic group are from alkanals down to amines. Carbonic group. What is carbonic group? A carbonic group simply means a carbon-oxygen bond. A carbon-oxygen bond via double bond. Okay, that's carbonic group. There's one important family here I didn't put here, which is alkyl halides. Maybe number 13. Alkyl halides. Alkyl halides. 13. Alkyl halides. Alkyl halide. Functional group of alkyl halide is X. Is X. And where this X can be F, Cl, Br, or I. Like methyl fluoride will be the example, perfect example. Methyl fluoride or methyl chloride, as the case may be. Okay, that is a functional group. We're going to be looking at nomenclature in organic compound quickly.